Are we live? I think we might be now.
Hello, my name's Mark.
Or maybe not, yeah. Let me just pull this aside. Has YouTube updated? Yeah. Of course, there's an error.
Hello, my name's Mark.
There you go. We are live. It's just not showing up on the YouTube homepage for some reason.
Hello, my name's Mark.
There you go. We are live. It's just not. Yeah. Let me just turn down the Spotify just a little bit, and here we go. It should be good for everyone now. Let me just turn this up, and I think it should be good now. I'm gonna turn on the comments here so I can see it, the chat. Chat is disabled for this live stream. Oh, it should not be. Let's see why it's disabled before I can start talking to you guys.
Hello, my
talking to you. Let's see if I can edit it and if I can get a chat. Yeah. Yeah, it actually is disabled for some reason, but why? Oh. Why can't I have a chat here? Ah, okay. There you go. It's because I put it as a kids stream when it's not really a kids stream, is it? There you go. There you go, I can see everyone now. Yeah, welcome to the stream, everyone. I don't think there's many people watching, but the plan for today is to basically to turn a very sort of simple coding challenge that I did a very, very long time ago, maybe 7 or 8 months ago, into a proper C++ library. And let me show you what the challenge was, but it's essentially a REPL C++ challenge. So if you know what REPL is, I think it stands for Read-Eval-Print Loop, or print and repeat. And it's essentially just like a little sort of like interpreter. So if you think of like your bash shell, for example, that's kind of like REPL in a way that you can have as many sort of functions or commands as you want. You can obviously create new commands and then so on and so forth. And you can type those commands on the interpreter, and they will sort of print the results and then ask you for a new command every time. And this is what this particular challenge was about. Let me just open that particular specs so I can show you guys, and then I'll take you through the code that I did at the time. Again, this was a very, very long time ago. This is something I recently opened up and thought to myself that it would be a very nice either video or a live stream to take you through an interview question like this and show you how I would personally approach this. So yeah, let me find the file in the first place. We're filling up our development directory with a lot of projects, which is definitely a good thing. But there you go, I just couldn't remember what the file was. So this is it. Let me also just keep a tab on the YouTube stream here so I can see how many of you are watching, or if there's anyone watching actually on the YouTube. There you go. So yeah, this problem was for a very sort of, I would say, kind of famous company here in the UK, and it was for a C++ senior developer role. And this is the specs for the coding challenge that I had to do, and essentially talk through one or two people in the team through I think it was a 2.5 hour interview regarding my solution. And as I said at the start of the stream, it was just a REPL project. And if you don't know what REPL is, as I've already explained, it's essentially like a little interpreter, or if you think of a bash shell, that's what you'd be implementing. And there were a few requirements. So you can see here you had a function that would initialize the library, so initialize everything you need for the library. There was a function that would shut down all the functionality that you would basically start up, or any commands that are still running by the time you shut down. And there was a function called poll here, which is essentially a function you call every time you look for your program, that will basically execute whatever is on the queue, right? So we might change one or two things here. I don't necessarily like this particular architecture. For example, I don't think you should have to initialize a lot of things in this particular sort of like a problem, because that kind of implies that you have a lot of global state that you're tracking and so on and so forth, which is not necessarily needed for a REPL library. But you know, we'll come to it when we come to it, I guess. And there's some examples here in the description about how this library should behave. So if you look at this particular example here, commands are provided in the format. You've got the command name, and then the argument 2, and then so on and so forth. And then the result would be returned. I think it says as a callback in here somewhere, which is not necessarily what we're going to do. We might just print these results to a logging system or the stood out, right? And yeah, I mean, I'm not going to take you through the whole thing, but you know, there's specification points after specification point here. There are a few examples of things you should already implement as a built-in command. So you can see here there's an echo command, there's a countdown command, which, you know, you just type countdown 10, for example, and the command will count down, we'll say 10, 9, 8 seconds remaining, and so on and so forth until it reaches 0. And I think that's pretty much it, really. It was actually not a very difficult problem per se, if you just want to do it very quickly. But I thought it was interesting regardless, because before this challenge here, I never implemented a system like this, so it was nice to see how I would approach it. And I've accidentally closed my tab here. Let's just open it again, see how yeah. There's 2 people watching it now, so I mean, if this is true, there's someone else in the stream, and you're welcome, and feel free to post a comment if you've got any questions or anything like that. Before we actually start this, let's look at some more examples of what we're trying to achieve with this particular project. So if I just open Notepad here, just as an example, say I want to create a program that will basically prompt you for a command. So my command, I can have something like an add command, and I can put 1 and 5, and then this will return me 6, right? That's what I want to do. And then you will just keep printing and sort of like querying more and more commands from you until you quit the program. So again, I can have subtract 5 and 2, and then you'll give me 3. As you saw, there were some examples from the challenge specification, like echo. So if I do echo hello there, or something like that, it will just say hello there. Kind of similar to what you have in bash, for example. And there was also a countdown, right? So there was a countdown 10, and this would as described in the actual specification, you would basically say 10 secs remaining, and once 1 second's passed, you'll say 9 secs remaining, and so on and so forth. You get the gist, right up to 0 secs remaining or something. Well, at which point you say ready or something, right? So these are examples of commands that I would be able to sort of input into this system that we're creating. But as well as that, it's not something that the specification asked for. I thought it would be very nice if we could, at runtime, provide our own commands. So I could essentially have something similar to Python. So I can create a function in C++ that will, I don't know, maybe play a sound, play an MP3 sound, and I can essentially call that something like play, and then my music.mp3, and that will return, that will just, you know, do the sound for me here, or something like that, you know. But I want to basically create this at runtime. I want to basically add this on my program when it's already running. And this is where the whole sort of like library architecture of this comes in, because I'm going to create this REPL software here, this particular piece of software, as a shared or static library. I don't know which one. Yeah, I think it's going to be a shared library in the end, in the way that anyone can include it in their programs, and whatever sort of interpreter they write, they will be able to add their own commands to it. So you don't have to modify the library itself to have more commands, if it makes sense. The library stays as it is. The only thing that you modify would be your interpreter. Okay. So yeah, I mean, this is the idea for this project, and I hope, you know, it makes a little bit of sense. So yeah, let's get started and let's see what was already sort of made, what I already wrote before here. So if you look at the code, you know, there's one main header, which is, I think, is an include here, and control.h. I don't think there's any, let me just check if there's any sensitive information before I proceed. Okay, no, I think it looks very fine, it looks okay. This is, you know, the main header that you'd include in your program if you're using this library, this REPL library. And at the moment it has, you know, a mix and match of different functionality. So you've got a few, you know, classes here, argument types. Presumably I wrote this to pass in arguments to commands internally, and this is exactly how it's used. I've got argument types here as a vector of argument type, which is just a vector of that kind of enum. And I've got the command argument itself, and you can see here that it's a variant, and this is not going to work in C++ 17 downwards, I think, but I think it will work on 17, but not anything below that. And essentially it just represents a command type, a command argument type, and it has to be a variant because as you can probably tell here from the usage, you know, I'm going to be calling a command and passing in you know, arbitrary arguments. It has to be a variant because it has to, you know, it can take many different types, right? So I chose a variant for that reason, and because it's a variant, things are more sort of like friendly at compile time. If something's not going to work, it's going to give you an error at compile time. Whereas if you use any, I believe, and try to sort of like unwrap things, you may have a few more runtime errors if you don't do it properly. Let me just keep this open. Okay. Now we've got the command handler type, which is a function that returns a command argument. Cool. Returns a command argument and takes in a vector of command arguments as well. So, you know, as many arguments as you want it to take. So this is the signature of a command function internally. So if you want to add a new command in the library, you're going to have to create a function like this and basically call one of my functions here at the bottom. You'll be able to see it in a bit with the name of that command. That's what's going to show up, you know, essentially here. And you know what function is going to call, which is the function you're creating in the first place. And you know, these are just things from the specification, which we'll probably remove quite a lot of because I don't really like how the specification turned out in the end. But this is what it is. You've got that function called initialize, which was, you know, actually given by me by the interview people. This was already sort of here, this particular declaration. And same with the shutdown, same with the poll. And there is a function that I added, wasn't part of the specification, which is called qcommand, which is I think I added it, I'm not entirely sure, I can't remember now. Which is essentially just a string. So you pass in something like, you know, cmd int qcommand, and you call it something like this, you know, add 1 and 5. This would come from your interpreter or your main program or something like that, and it would return you. It doesn't return you anything. It just returns you. I guess it does, right? It returns true if you successfully queued that command, and false otherwise if for some reason there was a particular error in queuing the command. Yeah, and this function here called register command, this is something that I added myself, and I do remember this actually, even though it was a long time ago. And this is the function that you call at the start of your command, start of your program, sorry, or during any time of the runtime, when you want to actually sort of add a new type of command, right? So if I, for example, I create a new C++ function that handles the subtract command as we showed before, you'd call it as cmd int register command here, and then you'd call a subtract, and then this would be that function object that we created here of this type at the top here. Okay, and that function has to take in a vector of arguments, and whatever it does to the arguments is handled inside the function. That's, you know, the user's problem, that, and it returns a command argument as well. Okay, and I'm not going to go through over this option that I added here. Is basically just to enable runtime checking of the arguments here. So you know, you can optionally pass a vector of arguments type that you expect this vector to have. So for example, for subtract, I expect it to have some sort of like integer and an integer as well. So if you pass in these argument types as a vector of, you know, int and int, and by that I mean the argument type, you know, it will check those types, right? But this is optional, and you know, we shouldn't really worry about this too much for now. We're just checking arguments. And then there is also the register callback. So this is something I did at the time. I didn't really like the implementation of this because it's like one global callback for all the commands that I finished. But basically the idea is that when a command finishes here, so whenever you call a command, you queue up a command, and that command finishes to running, whether it's in one thread or many threads, a callback will be called that basically says, hey, this is, you know, the command that you queued up, and this is the result of that command, right? Now let's start figuring out what we want and what we don't want here. So as I probably mentioned before, initialize is not something that we kind of need at the moment, right? And you can see it here. This is the actual implementation of that control header. All this does is essentially just creates a unique pointer to a command interpreter here, which is like a global interpreter. You know, I don't really like that. We have like essentially just a global interpreter. You can't have, for example, two different interpreters running at the same time in your program, because, you know, this is one variable here. So this is something that we're going to remove, and this is all that the cmd int initialize is doing. You can see here, and the shutdown is kind of doing, you know, the same thing. So yeah, I mean, all this does, it creates a new instance of this command interpreter class that, again, we're going to talk about. That's kind of a little bit important. So, you know, as you can probably guess, most of the API here for our REPL, you can see we've got the initialize, int, shutdown. It's all free functions. It's all fairly C-ish style, with the exception of, hey Miguel, how is it going? ¿Cómo estás, mi amigo? It's good to see you, man. Good to see you. I'm not doing too bad. How are you doing? So we're just making some REPL, some interpreter code. I'm gonna turn this down a little bit. It's still too bright. Let's try again. There you go. Now it's not as bright anymore. There you go. And where was I? Yeah. So as you can see, most of the functions here are kind of like in a C style, with the exception of the exposed strings. And this is because if you write all of your public API in a C style, you can basically call your header files from a C program as well. And if you're writing libraries that you intend for people to use in other programs, such as writing an interpreter, so if you think of something like Python, I'd probably assume that you're writing it all in a C style sort of API, because things just work better. You can use a program in more ways. If I was writing this purely in C++, even the sort of public API, I would not be able to use it in a C program. So we're going to change that as well. We're going to remove that. What I'm trying to say is that we're going to remove all these strings here. We're going to turn these into C strings, just as the entry points here, just so we can use it from a C program. Any news about C++ 23? I don't know, Miguel. I'm not really part of the standard, but I'm hoping that things will be more supported, if it makes sense, by the compilers. So there's a video I've made recently about the modules, C++ 20 modules. So if you haven't checked that out, do check it out. And it just goes to show you that even I think it's 3 years after the C++ 20 was completely sort of done, we still haven't got all the features. So if you look at C++ 23, it's even worse. I mean, we have even less features that are fully supported. But give it time. Give it some time, Miguel. Give it some time, and then it will all be done. So let's continue with this. So yeah. So now let me explain to you guys the architecture of this. So my main idea was to have one sort of class that we call it the interpreter. And the interpreter will have all of the actual functionality of my API in it. So as you can see here, I've got a register command. So you can do something like, you can register a subtract function. You can say, if I call the library here with subtract, I expect to have 2 integers, such as 5 and 4, and it will return me 1, right? Because it will do 5 minus 4. And this is what I want my program to kind of do at the start. So before I call this function, obviously, I have to register it. I have to basically say, whenever a user types subtract and passes in 2 integers, it will call this function here in C++, and it will return me these values. So that's what the register command does, and we can look at the implementation of it. It's actually very, very simple. I have a very sort of easy function that will split the string here on the space. Why do I have a split? Okay, yeah, so I'm just doing some checking here. I'm making sure that the command is one word only, one word altogether. I can have a command, for example, that's called sub and add or something like that. That doesn't work. It has to be one word. And once it's done that check, if it passes it, we then we go onto our command map, because we've got essentially a map that will store all these commands, right, and their functions. And if it already exists, if that command already exists in our map, it doesn't add it as well. You can see here it returns false. If all of these checks did pass, then we can add our command here to the map. So I'm talking about a map here, and you can see that the command map is essentially just a map where the keys are a string. So for example, add, and a command function that handles that command string whenever a user calls it. And looking back again, a command function is just a simple function here is a struct that holds a simple function taking a vector of command arguments and returning a command argument as well, one single value. That's all it is here. And this is the main sort of bread and butter of this program here. It's just a map that holds the command name and a function that handles it. That's all we have to do internally. That's all all the structures that we need to have, because the rest is just logic around that, if it makes sense. And this is how I approached it. This is how I approached this program here. I'm not sure if you're here still, Miguel, but I'm going over a coding interview that I got a while ago. So if you're interested, I can send this to you. It's without the name of the company. Unfortunately, I still leaked it. So like, if you're watching this on, tomorrow or something, I will have cut this from the YouTube video. Hopefully no one's recording this live though. Okay, Miguel, so now here it is. Let me just turn this to private, to public now as well, because I don't think there's any issues now. Change visibility, change to public. Of course I need to go on my phone and allow it. Jesus Christ, all this two-factor authentications here. Right, now this is public. Right. Let me know if you can access this link here, Miguel. And if you can, it's going to be right here on the specs.md file. This is the requirements. I will edit this later, so I remove some of the stuff that's not really necessary, but this is it. This is the specs. And it's essentially just for an interpreter, just like an interpreter kind of program. If you think of Python or Bash, that's what they're asking you to make. But let's go back here. So, you know, the main idea is to have a map that will control, you know, all of the registered commands. So if I open a whiteboard, maybe we have a whiteboard online here, so I can draw it for yourself so you can understand what I mean. Tell me this is free? Yeah. Okay, cool. So you've got like the little map, and we have, oh, even better. Can we have text here? Nice. Okay, how do I move this? This is terrible, dude. There you go. So we have the command name and we have the function. And let's go back to the pencil. Something like this, right? And this is what we store in this map. So this is the main idea. So we've got something like, you know, a string called add, and then on the function itself, you know, this is something that you create before in C++, but you'll be like the pointer to a function. So a function pointer or something, right? So basically, every time you register a command, you'd say, I want to register a command called add, and this function here that I've created previously to calling, you know, the register function is what's going to handle this command for me. So every time someone goes on my interpreter, and you pretend the bash here is my interpreter, and if I call add 1 and 2, every time a user hits enter, you know, it's going to take the string and actually call this function with 1 and 2 on it, right? This is the idea here. This is the main sort of, this is the bread and butter of this architecture. And this is what this is doing. Just essentially just that. This function is registering a command by checking that the command doesn't exist before and checking that the command is a valid name. In my case, it's a very simple check just to make sure that it's one word altogether. And if it doesn't exist and it's a valid command name, it just adds that command name to the map. And then the handler here, which is that function that we mentioned, something that you create beforehand, is just added to the map as well. Okay, so this is it. What else do we have in this class? We've got Q command. And Q command is the following. So every time, think of this as my sort of REPL again. Every time I do a add 1 and 2 here as a user of my library, when I hit enter, this is going to add this command to the queue to be executed whenever it gets executed, right? We don't really care about when it gets executed just yet, but it's just a single thread at this point. But it's just going to add this command string here, this command kind of request to our queue. And if you look at the code, it's actually very simple. We've got a function that is splitting the commands on the space here. So if I typed in add 1 and 2, it's going to turn this into a vector of add, a vector of a string, and then the next element of that vector is going to be the string 1 and the string 2, right? All as a string. This is what this is doing, and it gets the command name here. And this always makes sure, there may be a bug here, so we're getting the command name as the first element of the split commands, right? But think about, can this be empty, for example, if a user just types enter? This is probably a mistake here, so something we probably want to check now. Probably check what if string is empty. And this is something that I didn't really think about when writing this, but we're going to fix some of this. And then once we get the name of the command, we try and find it in the map, because if it's a command that people haven't entered before, we're not going to do anything, right? So we just got to make sure that the command exists, and if the command doesn't exist, as you can see here, if found is equals to the end of the map, if it didn't find, in other words, it's going to return false here, indicating that the command was not queued. Otherwise, we can continue for now. So continue means that we get the arguments, right? So we turn the first split command, the whole command, we just get the arguments out of it. You can see here, that's what we're doing, into this string arguments. And then we make sure to check if it's the right types of arguments. And again, we're not going to go too much into detail. Aí, Alan, beleza? Bom te ver, cara. Bom te ver. It's a friend of mine called Alan. We used to work together. A very good C++ programmer. Bom te ver, cara. Como tá indo? Como tá as coisas aí? Let me continue. So, once we split the program into arguments, we're going to check that the argument is what we expect. So, for example, the right size and the right types. This is what this code is essentially doing. And yeah, after it does all these checks, it finally queues the command by simply just pushing the command string itself, and then, the command the command function itself, and then the arguments that we have here, okay? And returns true. And you can see that there's two types of calls here. I'll explain that later. Tudo tranquilo. Que beleza, cara. Tá na Jaguar ainda? Tá trabalhando na Jaguar? Sorry, Miguel, you might hear some Portuguese, but I think you can understand it, right? You're from Argentina, so... So we queue the command. We've got a function that registers a command, a function that queues the command from a user's perspective. So when you have something like add 1 and 2, you'll queue that command. Estou sim. Sério, cara, de volta ao OBA? Que bom, que beleza, cara. Tá muitas saudades, viu, daquela codebase. Aquela codebase era maravilhosa, velho. Eu vou falar em inglês agora, que tem um amigo meu aqui também, mas yeah, I started a new job recently, actually. I'm working for a company called Hadian, sorry, and they are a startup in London. But I'm still in Manchester. I still live in Manchester, not far from Jaguar, actually, and I still see the guys sometimes. Lewis, Mike, and Dan. We see each other every now and then. But so Alan worked with me, and we had a very good, very good code base, a Jaguar Land Rover. It was a code base I actually liked working in, and I understood everything because he wasn't that complicated. That's what I could say about working a Jaguar Land Rover. É isso aí, Alander. Cara, eu mudei, tava na Microsoft por 1 ano e pouco. E depois saí, né, como contractor. I'm still doing C++, yeah, I'm still doing C++. I do Rust now. Eu trabalho com Rust agora, cara, acredita? Agora my full-time job now, I do Rust. C++ is just something on the side at the moment. And every now and then on the company as well, I have to look at the code base in C++, but it's mostly Rust. So yeah, I'm enjoying it. It's not too bad. You should get into it as well, I think you like it. So going back to this, we've got Q. And yeah, that's it. So let's try and actually test this. So let's try building this, right? I think I can build it here because I've got cool. Yeah. Cara, Rust é uma delícia de programar comparado com C++. Muito melhor, menos erros. Os erros significam coisas tipo, que você entende, sabe? I'm a first year computer science student. Can you suggest an easy programming language? Because I am finding Java a bit difficult. Ooh. Maybe Alan there can help me out here. The thing is, my guy, if you stick to any language, that being Java, JavaScript, C++, or Rust, and you learn it inside out, you figure out that most of them are quite similar. So, for example, take Java and C++. They have very, very similar concepts. You know, if you think of like object-oriented, you're thinking about classes and stuff. The way classes work in Java is essentially very, very similar to C++ as well. The way you write functions, it's again very similar to C++. So like, it just my tip is, you know, pick a language that you think is going to be worth it, and stick to it until you learn it basically inside out. Pick up a couple of books. Make sure you learn. You're doing a few projects by yourself as well. You know, there's GitHub. Maybe you can help someone out on GitHub by starting to contribute to an open source project on that particular language. Just practice, and you'll be able to basically pick up any language like this. Even now, as I was just saying to my friends here, Miguel and Alan there, I started a new job doing Rust, and it was actually extremely easy to pick up, just because I know maybe 2 or 3 languages quite well, especially C++, and you know, learning a new language is very easy once you do that. So just make sure that you stick to whatever you pick. Now, if you want to pick a language that has sort of like market share, let's say, that would be your best option, because then you learn a language that has a lot of demand, and you can look at Stack Overflow, for example, for the most on-demand languages of 2023 and 2022, and take a pick. I'm not going to say a name here, but you know, if you're a first-year programmer, first-year university student, and you learn a language, or that language that you pick throughout, you know, your 3 or 4 years that you're at university for, you know, by the time you finish, you'll be very good at it, and you for sure not struggle to find a job. Let's just put it that way. So, but yeah, practice is perfect. Practice makes perfect. Sorry. As you can see, I'm doing C++ here. This is the language that I basically chose after university, but during my time at university, I did a lot of Python, I did Java, actually, quite a bit. And yeah, I just made sure that I learned them. I really learned them. That's what I can say. So yeah. I'm going to try and build my project here, though, for you guys. And yeah, if you feel like you could learn 1 or 2 things from the channel here, make sure to subscribe and, you know, join the Discord channel as well. I'm always online there if you have any more questions. You know, we're here to help. Yeah, so let me try and build this. Let me select a configured preset. Let's go for debug. Yeah. The one thing, I'm going to call you David, is that your name? Davi. Is that, you know, languages like C++ and C, they are quite hard to get started with, just because the language itself isn't everything you need to know. Especially like if you look at C++ right now, actually on this project, there's quite a lot of CMake that I've written here, which is essentially something that you need to know. CMake, or writing make scripts, just to get your project to build. So maybe picking a language that has all that build system already in the language for you, and also maybe a package manager. So I'm working with Rust, for example, at the moment, and that language, it has a compiler, a build system, and the Cargo third-party package, dependency manager as well for you. It's actually very nice to have, because you don't have to learn a lot of different things just to get a very simple project out. So look at those things as well when you're choosing a language. Yeah. Let's do a clean build here. And let's take a look at the test that I wrote before. So if I take a look, there's quite a few tests here that I wrote for this particular interview question. And again, David, if you're interested in the interview question, I think I dropped the link on the chat here. If you just go up above, and this is what we're trying to solve here, me and Miguel. It's just like a simple interpreter, command interpreter. There you go. Let's take a look at this test here. So if I debug this program, let's look at the idea of this test. This test creates it registers a new command, right? Called callback. It registers a callback actually. It registers the command called add, which is handled by this make add command function that's returned here. And the add handler just simply takes, as I said, the arguments. It checks that there are at least one argument, I guess here. I don't know, you can call it with 0 arguments. But it just, it takes all of the arguments, tries to convert them to integers, as you guys can see here, and then just sums up the value and returns the sum, right? So every time a user calls, add 1, 2, 3, 4, 5, or whatever, it's going to take the sum of all of these and then return that to the callback. And that's the idea of this test here, is just making sure that that actually works from the library that I've created. Let me just drink some water because my throat's getting quite dry. And then we can actually begin to debug this. So let's create a JSON file, a JSON debug, C++ launch setting here. Let's name this, I don't know, the REPL test, right? And then the program is going to be inside, let's see where it's going to be. Build Unix CMake. This is just where CMake puts all my build stuff. Unix debug. Oh, we've got sanity tests. Okay. Yeah, I think this is all we need for now. So if I actually run that test, my breakpoint should be hit. Let's see. There you go. So let's debug this. So here I've created my callback function. The callback function for me is very, very easy actually. It's just whenever a command finishes running, it's going to set this variable called result to whatever the result of my command was, right? Just so I can check that result. Essentially that's what it is. It's actually a very, very easy callback. So I'm registering the command and then I queue the command. This is the important part. After, you register a command, you can call queue command with whatever data you want. This could be something that the user typed. So I could have typed add 5 and 11 here. And once we call poll, which is, as I explained before, this is the function that actually executes the commands that are in the queue. The result should now be 16, right? Because the command ran, it finished. Oh, sorry about that. The command ran. In other words, add 5 and 11 did run. And then once it finished, it called my callback function here. And then my result is basically 16. That's all it means here. I will shut down. And that's it. That's what the test does, and it kind of works. Very easy, very simple, just for you to see that whatever I've written here actually does work. And the idea is to now turn this whole architecture into something actually usable, something actually, that's not basically shit that people actually want to use in their projects. So the first thing we can look at, now that you guys are hopefully very used to what the problem is, let's take a look at the public API and see what we can change. And one of the first things that I noted here is that I've got quite a few things being exposed to the user here. So I've got my argument type, I've got my types here and whatnot. And this is not too bad. I guess I have to at least expose the function type here. But what I can actually note is that this function type here is only available in C++, and same with the optional argument types here. These two things are only sort of available in C++. So as I explained before, I'm not sure if you guys were here, if you are exposing your public API, your public C++ API, and that API has a lot of C++ types in it, people writing programs in C will not be able to use that just because they won't be able to to include, for example, string on their programs. They just won't have access to it, right? So one of the good things that we can do is basically just remove these things and turn it into a pure C public API at least, and everything else internally, the way I do things, the way I have a C++ map, the way I handle strings internally, that can remain the same because that's not going to be exposed to the user, right? Another thing that I also don't like is the initialize and shutdown things here. So these two functions are only necessary because, if I'm not mistaken, in the actual specs here, let's have a look. The actual specs of our program, the requirement was to have just one interpreter on all the time, right? So you have a singleton, and that initialize and shut down basically are just initializing and shutting down that singleton interpreter, which is fine. It's not too bad. But if you want to have more than one interpreter in your program, you can't just do that. You have to actually basically return to the user a pointer or something like that to the interpreter object, right? So that's one of the changes that we can make as well, right? And let me just find the specs here so we can see it. Yeah, initialize is called to initialize any resources of the library. It didn't actually say the word singleton anytime here. It's just something that I assumed myself, which is, from what they wrote here in this job requirement, this job challenge requirement, it made it sound like that. So, but yeah, that's something we can change here. So instead of having one initialize, what we could have instead is something like whatever the interpreter type is here, we just return a pointer to it or something like that. We do initialize in the interpreter. No, just a for here, okay? But yeah, that does mean that the user then has to basically handle this pointer here. And in the same way as we have a new initializer returns a pointer to an interpreter, we can have something that returns a void essentially, and it's called destroy interpreter or something, right? Destroy interpreter. And that will of course take the interpreter here that you want to destroy, right? So this is essentially how we can change this particular library to make it a little bit more friendly, so you can have multiple interpreters running in the same program, right? Which could be a use case. There's this function called poll. This function essentially, executes all commands in the queue, right? And I know that because if you look at my class implementation of it, and you can see that it goes through all the commands in the queue and executes them one by one. That's all it does, right? Yes, there's a little bit of fancy C++ lambda stuff here. Oh no, it's not that fancy actually, it's just a return type. But essentially, however many commands you've got on the queue now, it will execute them, and that's what this does. We can change the name of this. I don't really like the name Paul, so we can maybe call this execute commands given you have an interpreter, right? You pass in the points to that interpreter, right? Okay, and then register command. This can be kept the same. Let's move this to return a boolean. Actually, that boolean type doesn't actually exist in C, but we can keep it here for now. We can call it register command, and again, pass in the interpreter first here, and we have to change the string types to a C string as well here. So const char star, or simply just char star star, right? That's the actual string type command, and then you have the function pointer here. I think I actually forgot how to write function pointers. Function. Yeah, you've got your function pointer, whatever it is. Gosh, I've not written them in such a long time. I actually forgot the syntax. Or just in C. There you go. Yeah, I was nearly there. So is the function called here? And then we've got the archetypes. This could be a potential C++, sorry, it's potential C alternative to this API. And the same thing with, the Q command. E aí, cara, te acompanhando faz uns dias, teu CMake Products me ajudou bastante. Que bom, para setupar projetinho de C. Primeiro vou estudar C e depois C++. E aí, Rafael, uma boa ideia, cara. É uma boa ideia. O C é claro, um pouquinho mais simples que o C++, né? Ele tem menos conceitos. Ele tem menos bloat, que eu chamo, né? Bloat é o que deixa, tipo, com a barriga cheia, assim. Mas é uma linguagem boa de saber, porque ele tem fundamentais muito importantes para o C++. Basicamente, o C++ veio do C, né? Então é bom saber. Mas o C++ também é bom saber por causa que tem muitos projetos feitos na linguagem, né? Tipo, qualquer coisa feita com Unity, por exemplo, qualquer coisa na área de jogos, etc. Tudo é C++ hoje em dia. I'm going to continue to speak English. I hope that's okay. If you understand, feel free to drop a question. Pode, sempre que você colocar um comentário em português, cara, eu vou tentar ler. Mas o português tá ruim pra caramba, essa é a verdade. Sorry guys, I'm going back to English now. So yeah, we've got a Q command, which could be sort of like, the same sort of API. So we've got a Q command, and we can take that interpreter pointer here, and then the actual char star as the command here, the command string, right? And register callback. I don't necessarily like the idea of having one callback per for the whole interpreter. So what I'm going to do is, on the Q command, we can also have a function pointer here. So the callback, call the callback, right? And that will take the argument type as an input, right? The words are just running out of my head right now. So basically, this is the callback that will be called whenever a command finishes. Whenever this command finishes, at the end of that execution, it's going to call this callback with the return type of the command. And I hope that makes sense. Which means that this function here will just go. We don't need it if we implement this. So, does this look better than what it is now, though? That's what I'm wondering. Because yeah, sure, it should open up doors for the C programmers to use this type of library in their code. But handling all these, making sure that you always initialize a pointer properly and you always shut down the interpreter properly by calling the destroy interpreter function isn't necessarily ideal for me. I would much rather have a unique pointer for this, which kind of is making me think, what kind of command this interpreter is supposed to put? So Allender, right? On the job specs, if you, I'm going from the an interview challenge that I received about 6 or 7 months ago. Actually, might have been 8 months ago. They only wanted, I think, is two commands. So there's an echo command. So for example, you've got echo hello world, and then it will show you hello world, kind of like I've got it here. So this type of input here. And you've also got a countdown, which you say countdown 10, and it will show you 10 seconds remaining, 9 seconds remaining. It'll keep printing that until all the 10 seconds have passed. However, for this project here, we are adding whatever type of command you want. And let me just whatever type of command that you want. So by providing this function here to, now let me change this. By providing this function to register a command, right? Whoever is included in your library can just call this with whatever handler function they have here for any command. So I can essentially just say, I want to register a function, a command called subtract, right? That's the example here. And it will be handled by the subtraction handler, which essentially just takes some integers, int and an int or something like that, right? This is the idea of this, and it works so far with this current implementation that I've done before, but I'm trying to improve it, as you can see here. So I'm wondering what looks better, a C library, a C API, a C public API, or a C++ public API. Okay, because at the moment, we've got shutdown and initialize functions that just handles a singleton. So you can have one interpreter per program. You can't have two different interpreters running in the same program, which is, probably not necessary for most people. But if you have something like a game that's running some interpreters for your characters, right? The users can write plugins for, that might be a problem. If you think of Lua, for example, Lua kind of enables this functionality. That's not going to work because it's singleton. So I'm, redesigning the API to make it work a little bit better for us. But at the same time, I also don't like the idea of letting the user manage this pointer here, making sure that they call the shutdown stuff properly. So I am really thinking, why don't I just write this in C++ in the first place? So the alternative would be, I can have a unique pointer to my interpreter here. And I don't have a shutdown anymore. I mean, we don't need to. I mean, maybe we do, but we can just have the destructor of interpreter here handle that for us, or create interpreter. So this is what I'm thinking. I'm just, going through the ideas and seeing possibly how you can approach this if you were to do this properly. This is what I was trying to do on the stream today. What do you guys think? Any ideas? Kik se acha, Allender? Kik se faria aí, cara? If it was me writing, I would just go straight for the C++ idea here. And I think that's what we're going to go for in the end anyway. Indeed, yeah. What target audience you're trying to achieve. See, in the actual job specs, and that's something that people, I don't think there's many people watching now, but if you guys were doing this interview here, it does actually say that you should keep the API compiling for both Linux and Windows, which is fine, and maybe it should be used for, I'm not sure if it says here for C, so they don't actually say whether it should be used for C at all, but something to think about, I guess. I think C++, yeah, C++ would be interesting. I do prefer that one, so let's keep that for now. It's just maybe not needed here. So the first thing we need to do is actually, maybe we expose this, because I wrote this as a pimple kind of thing, so I pointed to implementation. Because I was trying to hide all of these classes, the interpreter classes, from the user, right? But now we can probably expose this, right? Because we're going to be writing a unique pointer to this, which, yeah, sounds good. Sounds good to us. Sounds good to me, at least. Even though, yeah, let's not worry about the flexibility for C now. Let's do it in C++. So the first thing, yeah, let's change this namespace to maybe something like that, interpreter. Change this to REPL, right? And then this is just going to be called interpreter. Actually, let me rename it everywhere. Okay, we apply to all of them. Command callback. Where is that? Let me change all of these namespaces. And these include export headers as well. This will need to go. This is something stupid that they gave you in the interview for some reason. They gave you the exports header instead of just doing it on CMake, and it's wrong as well. It doesn't work in some of the cases. I tried it before. Pretty sure on Windows it doesn't export it very well. So this is something that we're gonna redo with CMake. CMake has export header generation. I've got an example of this in one of my libraries here. This is what I mean, Allender. So you can see if you look at this one here. Where is it? Where is it? There you go. CMake generates the export header if you do it something like this. Generate export headers, and there's a function called generate export headers. It will generate the headers for you to include on both Windows and Linux. Are you OP for? I'm afraid. EXE, hi, welcome to the stream first of all. And I don't know what OP for is. Wait, is that something I should know? I'm professional development maintaining. I don't think I am. I don't know what that is, but maybe if you explain, I'll let you know. But anyway, Allender, yeah, CMake generates that for you. It's a really nice feature from CMake. Yeah, it is. Yeah, I read it on the book that you gave me, I think, quite a while ago. I still use that book, man. I still use that book every now and then. So thank you. Muito obrigado, cara. Foi a melhor coisa que eu recebi. So yeah, that's something that we're going to remove from here as well. And then we're going to replace all of the command int with REPL, because we're going to change this. All right, let's just try and build it. Let the compiler tell us where to replace. It's okay. Okay. See, one of the things that I don't really miss from C++ at all is the errors. Look at all these really ugly errors. I mean, these are fine errors, but sometimes you get linking errors that are just too much to read. What is the issue here? Argument type has not been declared. Argument type. Okay, let's try that again. Okay, good. So command interpreter is not there. I made a miss. I don't know what that means. I mean, sorry EXE, I don't really know what that means, man. You're gonna have to explain a little bit more. I'm gonna actually Google that because I have no idea what it means, mate. Am I a creature born with severe birth defects? I don't know, you tell me, mate, if that's what you meant. Maybe I am. Anyway. Command interpreter, again, is not here. I have no idea where I even defined this, you know. Command interpreter. Oh yeah, I haven't, because I renamed it, didn't I? It's just called interpreter now. Oh gosh. There you go. Mano, em português eu, velho, sempre uso. Falei inglês também? Eu nem vi, cara. I have no idea what this guy means. I'm trying to understand. Interpreter. Yeah, sometimes the English, when I'm talking in both languages, you know, it does mix in my head. Okay, I've got that, and this is not DCMA3. Alright, let's just... just use my Vim here to replace all this stuff, and then the command interpreter will just be interpreter. Right, yeah. Okay. I mean, this still needs to be command interpreter REPL, I think. Right? It does. Interpreter, right? No errors now. Why is this not working? Yeah. To finish watching, I'm gonna go for... Vai lá, Allender. Valeu, viu? Por assistir. Foi bom falar com você, cara. Vamos combinar uma call, alguma coisa assim, cara. Vamos se falar. Foi um prazer aí te ver de novo, então é isso aí, velho. Uma boa sorte aí pra você, viu? Até a próxima. Alright. Okay, so what is going on here? Interpreter is not a member of that. See you in the new video. See you. Hello, Allender. Ciao, ciao. Okay, and this we've got here too. Okay, so these are the tests. Just doing some renaming. Building further, but we're still gonna get errors, obviously. REPL. We're still gonna get errors here. There you go. Okay, good. We're getting there. Slowly getting there. No, not one. Yes, on that one. There's not one. Yes, on that one. There's not one. No, no, no. Yes, on that one. Yes, on that one. Yes, on that one. No, this one. No, this one. Okay, so we've renamed all of them. Let's see if it builds. It won't build because I've missed one, I think. Right about here. There you go. I'm going to change this later as well. Okay. If you're wondering why I'm typing, it's just a Vim command to rename everything, by the way. It's just a renaming. Okay, everything built now, so I've changed some of the names, which is good. It's a good start. Lib exports, we're not going to need this header, because as we know, CMake has export header generation. What can we do before we finish the stream, because it's actually going to be a very, very long bit of refactoring in the code from the looks of it. So I'm going to do it again tomorrow. I'll maybe do it again on Wednesday as well. So yeah, I mean, the idea was to really expose, I guess, expose this interpreter class, right? That's what we want to do. We want to expose this interpreter class so that we can have a function that will make that interpreter and give it to the user, right? That's what we want. But right now, this is obviously in a, where is it? This is all in one CMake lists, right? And we don't want that, yeah. And also my camera quality is absolutely terrible, guys. I'm sorry. Can I somehow change it? Sharpness is the issue, isn't it? There you go, a little bit better now. Yeah, before we finish the stream, let's just write a CMake list for this class that we called it the interpreter. So the class that we're going to be sort of giving the user access to, right? Let's just put it here for now. You will change in the future. So essentially what we want to do is like have a function, have another directory called interpreter. And this is where all the the interpreter stuff is going to go on. But I'm going to leave this CMake lists right here, right now. Well, let's call it REPL interpreter. And this is going to contain which files are we going to use? Yeah, the interpreter impl, definitely, that's what we want. For now, and we also want to do some sort of like target, include directories. REPL interpreter will be coming from the include directory, right? So everything in here, anyone that is kind of including the REPL interpreter will be able to publicly access, which is fine, which is definitely okay for now. I'm gonna be very cheeky and copy some of the code that I had from my base64 library here to generate the export header for me. So I'm gonna just look in here, copy and paste this. So right here, because it is something that we need in the end anyway, so I might just put it now. So set base64, set interpreter. So we've got here the command line interpreter still there. Yeah, I want to move that in there. And this is obviously going to break the whole build if I just proceed with the whole thing. But at least we can duplicate this and copy over in there. Can I do that? Yeah, I can duplicate it. Nice. I'm restructuring my whole CMake now before we make even more breaking changes. So we've got include here. Let's put it all in here actually. Let's copy it all in there. Okay. Okay, good. Kind of looks like what we want it to look like. In our main CMake list, before we break everything, because this is CMake that I received, most of it is CMake that I've received and added a little bit to it from the challenge itself, right? So you can see here, there's some weird checks being done for pointer size. Let's just add a subdirectory of source interpreter. Okay. So source interpreter is not an existing directory, is it? Interpreter. There you go. That's better. So CMake get property could not find target base64pp, and that's because I copied and pasted things without changing the names to it. Right. So let's have a look. There you go. So it's REPL interpreter. What is this? Export file name. Interpreter export file. What was it meant to be? Out of interest. Okay, I think this is actually an issue, which means I have to fix on my other repo. This was meant to be just a export directory, I guess, and the file itself was meant to be this plus whatever that is. So let's go with that. Export directory. Okay. Export directory, and then we can have interpreter export, right? And then we can do a CMake configure again. So reconfigure. Let's see if it works now. Okay, it doesn't work. Cannot find the source file. Command interpreter impl.cpp. Command interpreter command inter. I have no idea why I added an extra caption there, but now we're good. And if we actually look at the include directory, we have interpreter, you know, the actual properly generated export directories, which means, by the way, if I go into my class now, right, and if I go into my main class here, I can actually include that. I can say include, and what is it called? This is REPL. I forgot what the directory is called. Interpreter, just interpreter. Interpreter export, and this should work. And what I can do is I can just call this here. All my classes, right? So I can do something like this. If I want to export the struct, I can export it like that, right? But I'm not sure if I want to export this particular one here. What I do want to export is for sure this. Okay, this is a good song, but I don't think it's DCMA's free. Going back to the code, yeah, I mean, this is how we properly export things with CMake. So that bit is done. Okay. I'm walking the king. Is there anything else we can do in 10 minutes before I close the stream? So let's look at the plans, right? We made some plans here. If I look at my control, so the main idea was to have a function called make interpreter, right? So we're gonna change, we're gonna add that function here, maybe something like no interpreter. If it's here, is it here? Yeah. interpreter is here, right? Yeah, there you go. Make interpreter. And this is essentially what we want to have there. Oh yeah, actually needs to be done. What else did we have? Maybe it's easier if we just include the side to side. This function here and this here. I mean that file there and this file there. I'm gonna zoom out just a little bit. We don't want to initialize anymore because we have this make interpreter that actually creates our interpreter for you and returns that shared pointer. CMD poll. We want the execute function, don't we? Why is it not showing me? Oh, okay, yeah, because it was on the CPP file instead, all the plans that we've made. There you go. So we've got this one. We don't really need a destroy interpreter. What we do need is also to do here. It may be a custom destructor. No, it doesn't really need a custom destructor for this this type here, because we don't really have anything exceptional being done in the class itself when it comes to destroying it. In fact, we don't even define a destructor, so it doesn't really need a custom unique pointer destructor. We do need a function to, yeah, I mean, we need to rename this, execute commands or something, right? We do have a register function already. We have a queue command already here. And that's pretty much it. I mean, this should be the plan. So maybe when we do this again, maybe tomorrow or the day after, I will begin to actually break everything properly and remove the old version of the API and replace it with this exported class here, right? So that's a little go. Guys, I'm gonna leave the video here because I've been doing this for about 2 hours. 2 hours? Yeah, nearly 2 hours now. And I'm getting quite tired, given I've worked the whole day. So, you know, thank you if you're watching this in the future, and bye-bye.